Hello, today our topic is analog pulse modulation. Now modulation, pulse modulation means the carrier signal is pulse. There are two types of modulation, basically continuous wave modulation and pulse modulation. When the carrier signal is continuous, we call it as continuous wave modulation, and when the carrier signal is pulse in the form of pulse, we call it as pulse modulation. Now, pulse modulation is further divided as analog pulse modulation and digital pulse modulation. In case of analog pulse modulation, the modulating signal is analog, the carrier signal is pulse. Analog pulse modulation can be divided as PAM, PWM and PPM. PAM means pulse amplitude modulation, PWM pulse width modulation, PPM is pulse position modulation. Sampling is the process of transmitting signal in the form of pulses by using special techniques. The signal is sampled at regular intervals such that each sample is proportional to the amplitude of signal at that instant. This technique is called sampling. Sampling is common in all pulse modulation technique. An analog signal, suppose, is sampled every Ts second. Here Ts referred to as the sampling interval. Therefore, Fs, that is 1 by Ts, is called the sampling rate or sampling frequency. Now, there are three sampling methods: ideal sampling, natural sampling and flat top sampling. When we multiply the modulating signal, or the modulating signal is sampled at each sampling instant, then we call it ideal sampling when we multiply it with train of impulses. For the case of natural sampling, a pulse of short width and varying amplitude we get. Here what happens, the modulating signal is multiplied with a train of pulses. Flat top sampling. Here it is same like natural sampling with one change, that is the top of each sample is not containing the shape of the modulating signal. It is flat, having the highest or peak value of that sample. Now, sampling theorem, also called Nyquist sampling theorem, it is a continuous time signal may be completely represented in its samples and recovered back if the sampling frequency is Fs, that is greater than twice Fm. Here Fs is the sampling frequency and Fm is the maximum frequency present in the signal. The simplest of all analog modulation is pulse amplitude modulation. Here this is the modulating signal, a continuous analog signal, and it is multiplied. Here we have shown the case of ideal sampling. It is multiplied with a train of impulses. As a result, we are getting these varying amplitude train of impulses. That is it is sampled. This is the case of flat top sampling. Here the three techniques are shown. This is the ideal sampling, where the modulating signal is sampled at instant. Here the samples have finite width and their top is following the shape of the modulating signal. This is called natural sampling. In case of flat top sampling, it is holding the highest value and the top is flat. Therefore, it is more immune to noise. If we pass the sampled signal through a low pass filter, then we can get back the original signal. or original analog signal. Now there are few drawbacks of PAM. That is, the bandwidth requirement is large compared to the maximum frequency present in the modulating signal. Interference is also maximum in PAM and peak power required by transmitter varies. So, as an alternative technique, pulse width modulation is chosen. In this type, the amplitude is maintained constant, but the width of each pulse is varied in accordance with instantaneous value of analog signal. This is the case of pulse width modulation. Here width of the pulse is varied. When the modulating signal amplitude is maximum, the width of the pulse is maximum. When the modulating signal amplitude is minimum, the width of the pulse is also minimum. So, the pulse train width is varied in accordance with the amplitude of modulating signal. In pulse width modulation, the width of each pulse is made directly proportional to the amplitude of information signal. The next one is pulse position modulation. In this type, the sampled waveform has fixed amplitude and width, whereas the position of each pulse is varied as per instantaneous value of the analog signal. PPM signal is further modified form of PWM signal. Thank you.